Okay, hello guys, good morning. Welcome to Live Maths, Paul Tutor's Maths. Give me a little like if you're up for it. Subscribe to the channel if you haven't. Follow me on Instagram if you want any A-level math related content. Might start doing some further maths related content as well, and GCSE. Let's see how it goes. 2 questions, 1 AS level question today, 1 A-level question as always. You've got all the other live maths in the data bank if you want them. 11 or 12 different recordings, exam style questions worked through. You might not need them right now. If you don't have an exam, they've been cancelled. You might need them in the future. Let's see what's going to happen. Let's see how it goes. Or you might just want to keep yourselves sharp, fresh, and the cutting edge of the mathematical world. Here's a question. It's the AS level one. You might have forgotten it if you're an A level. I don't know. I don't know what your memory is like. Where you dropped on your head when you were a child. These are things I don't know. What I do know is that this is a function of some description. I'm not even drawing that one. Let's just draw a totally random thing, all right? Could do, I don't know, anything you want it to do. Absolute, it's like Table Mountain, some sort of mountain-related thingy. And so what does increasing mean? Let's just quickly do it. I don't want a full... So A level coming up after this, okay? 1 AS level question, 1 A level question, and they're both exam questions actually, so they'll be from A level papers. Where's this function increasing? Where the gradient is positive. So this bit here, up to there, looks like it's increasing. This bit kind of looks flat, to be honest. Then again from here, maybe I can like do that. Increasing. And then this bit down here is decreasing. So we'll just do like a double dotted line. All right, so positive gradient, and then here you've got negative gradients. So that's the idea of increasing versus decreasing. I'm not going to say anything more than that. But that's the visualized vibe of it. How do we actually prove something is increasing or decreasing? Well, I did give you a little bit of a spoiler alert, hint. Well, look at those ones. When it's increasing, positive gradient. When it's decreasing, negative gradient. And then it's kind of intuitive. If something's going up, it's increasing. If it's going down, it's decreasing. Anyway, too much talking, not enough writing. Remedying that now. Stats pronto. Lights, camera, action. Well, I'm off. I am differentiating this thing. Why am I differentiating this thing? Because someone once told me that the derivative gives you gradients. All right, derivative gives you gradients. So I've differentiated, I've got my f dashed x, and really this thing here, if I plug in an x value, it'll give me the gradient of the thing. So for example, at x equals 1, the gradient would be 3 minus 6 is minus 3 plus 15 is 12. So the gradient of this graph at x equals 1 is 12. How can I prove that the thing's always increasing? By the way, I guess visually, this is what that would mean. Cubic. You look at that. Always going up at every point, that's a cubic, where the gradient is always positive. It's always increasing. Oh, let's see, camera issues. That frequently does happen. Come on, my lads, let's get you back in. Okay, so there's positive gradient all the time cubic. That's kind of what we're drawing. So how can I prove that this thing is always positive? So there's a couple of different ways to do it. What I quite would like is, you could do completing the square. Let's see, does that work? What if you complete the square? That would mean, how would you do it? You'd pull out a factor of 3 there, and then you'd have x squared minus 2x plus 5. Then you could complete the square on that. Don't know how you complete the square knowledge is. Have you done that recently? Do you remember that? So then you'd have 3 times x minus 1 squared. That would be plus 4 times that's plus 12, I think. So that was just doing it turbo. I think I got that one right. So the low point of this, the minimum it can be, if you remember you're completing the square, is 112. And the lowest y value it can have is 12. Okay, so you could say something like that. There's your derivative, complete the square. That's the minimum point. I think we've all forgotten our AS, even me. I could do with a recap now and again to keep it fresh, but here we go. So, yeah, first derivative, there you go, that thing. So I would say, so f dashed x, always positive. It's actually always bigger than 12. It's even more than just positive. And you could say, therefore, increasing. Okay, you know that's a minimum because, it could depend how strict you want to be. You know that's a minimum because that's a quadratic that's a smiley face one. You could do other tests. You could do second derivative and show that the second derivative is, what would it have to be? It would have to be positive or something. You'd have to, or yeah, okay. But let's not get into it. You could do a second derivative test just to check that that's a minimum point. All right, but I don't think it's worth your while going to all the stress. Other ways you could prove this thing: you could find the minimum point. You could differentiate it and find the minimum point that way. Differentiate it, set it equal to 0. Anything else coming to mind? There's probably some other ways you could do it. That's probably the two best ways. Differentiating it, finding the minimum point, and therefore all of the graph, if you roughly sketched that graph, it would all be above. And when we talk about it's got to be bigger than 0, this is the graph, if you like, of f dashed x. If that's the minimum point, 112, then there's nothing which is negative. No part of that graph is below the x-axis. It doesn't have any negative y values. Okay, turbo recap, then on to the second question. There's a random graph, all right? I just drew it. It looks a bit weird. I don't know. It's not going to win any graph drawing awards, but it does convey the key points. It's some random function, and what does increasing and decreasing mean? Visually, it's increasing if there's a positive gradient. Positive gradient means slanted, this is GCSE days, positive gradient, negative gradient. So increasing, and then when it's dipping down, you get a negative gradient. How do we show that our thing looks a bit like this, i.e. it's always positive? Well, we want to show that it can never have a negative gradient. Differentiate it. Can this ever be negative? No, it can't be, because its minimum is 112. There's no value of x you could ever put in there. You could try for years and years, but it's unlikely. If you did actually, I would be interested to hear from you. If you managed to find the value of x that does make the thing negative, that you're getting an award. I'm not sure what I would do. I could give you a chiseled golden calculator, which I've handmade, but no, it's not happening. I always get distracted with my little internal thoughts inside my head. We need to stop that. So f dash x is always positive. It's increasing. What are people saying in the chat? Yes, U shape is a minimum. N shape is a maximum. Smiley, frowny. You could do what you're saying, Rachel. Exactly. Second derivative, and then you'd plug in x equals 1. So you could do second derivative, which would be f double dashed x equals 6x minus 6. And then you could plug in, well, actually, you might need to do more tests on that. Does that tell you it's a minimum? Is 0? Have I done it correctly? 3, 6, and that would go to, is it definitely x equals 1? I think so. So actually, looks to me like, unless I did that wrong, here the second derivative test might not work. You guys check it for me in case I did it wrongly, but for x equals 1, you'd have 6 minus 6 equals 0. So actually, that's not great. When second derivative equals 0, you need to do more tests. But you're right, if the second derivative gave out a positive number, just very quickly say it, then I'm moving on. If the second derivative is bigger than 0, that implies that it's a minimum. And if the second derivative is less than 0, that implies it's a maximum. But, as we just saw there, if the second derivative equals 0, you need to do more tests. So that's a problem, potentially. Anyway, don't need to worry too much about it. But that's an interesting little point. I'm moving on. By the way, exam board, this one I think is AQA, the one that I just did. The next question is not an exam board one, it's from the Madass Maths website. Because I was doing a lot of Edexcel, most of my students are Edexcel, and they're in tears. They come to me in floods of tears. I'm a kind of grievance counsellor more than I am a maths tutor, because the new specification is horrific. Horror story, you know, nightmares with sort of differential equations kind of crawling up beside your bedside, coming under your bed covers, causing problems. So I'm trying to find as many questions as I can to deal with the new specification. There's only a certain number of style questions. It's hard to find the Edexcel type questions. Madass Maths has some good ones. OCR spec's getting harder too. So is the MEI. Cambridge Pre-U, yep, that's got some reasonable questions as well. They're all getting tougher. I think in particular the Edexcel one though has been an issue. And also I would say that if you're doing an A-level, if you're doing a maths A-level, more than other subjects, you can try stuff from other exam boards. It is all quite similar. There's definitely some differences, but generally don't be shy. It gets you more practice, you'll be a more rounded mathematician. Okay. Yep, sorry Rachel, I'm a bearer of bad news. There's no point lying to you. I'm not going to pretend that Santa exists or something like that. I think it's better that you just know the truth about the matter, and then we can deal with it together. Here we go. Here's a good way to start dealing with it together. An absolute monstrosity of an exponential solve. It's going to take me probably 10 minutes to write the thing out. E squared. Da, 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 da. So, just about got there. Pretty tired after that. I'm going to take a 2-minute break. Did I actually do it correctly or not? I did it fine. I think for this one, I'm going to keep going. I'm just going to go with this a little bit and then stop and recap, and because otherwise I talk too much. And only thing I will say is, fair enough, there's different things you might want to try with this one. I'm not saying you could get the right thing first time, and there's maybe more than one way to do it, but this is how I thought to do it. What do we do with that again? Yeah, this. Camera okay. And this is, you're not going to get any graphs today. You're not going to get any graphs today, guys, I don't think. You've had all your graphs. This is going to be an algebra fest. Look at this blank paper, just waiting to be filled with exponentials, logs, algebra. Yes, I see you've mentioned logs. Liking it. Liking the idea of logs. It's going to be about, they're going to come up at some point, probably. Just a case of when are they coming up. Let's not do them too early. And when they do come up, let's use them properly. Let's see. So first thing I did is complete the square on that bit. Let's just do it again. Some of the stuff I'm doing might seem absolutely mad, but maybe as time goes on it'll make some sense. Let's see. So -4, so that'll be +1. Okay, so all I've done so far, I don't know, I just noticed that's x -2, and I noticed if you complete the square on that, I know it's a power, which is pretty horrendous. You wouldn't usually see the quadratic as a power like that. I mean, not nice. Anyway, let's not stress about it. Just complete the square anyway. And if you've done your GCSE completing the square, we just did it in the last question. It came up twice. Then someone could approve to you the fact that this is true. I'm happy to be that person. And you can write it like that. So now what can we do? Next step. Well, I really want that. I really want that to look like that. It's a Spice Girls type situation. I really want an x -2 squared. So what can I do to get that? Well, Let's just do it and then maybe talk about it. 2. And also you need to be really slick on your powers rule. That's why I like this kind of thing. It gets you practiced on loads of things. Algebra, power rules, exponentials, everything. So e squared, and then it's to this power. That's power rules. You know, x to the a to the b, if you like, equals xab, i.e. x squared cubed equals x to the 6, right? X to the 2 times 3. So that's all I'm doing here, timesing that 2 through. Looks like that now. Now there's another rule. Let's just do it. And again, talk about it. E to the 2, x minus 2 all squared times e squared equals. I mean, this right-hand side, honestly, this right-hand side is just along for the ride so far. Absolute, I wouldn't say hitchhiker, but just hopping on board. And I'm now not a scrounger, what's the right term? I'm not sure. But adding nothing this right-hand side, what a joke. Come to him at some point maybe, but for now, freeloader. Here to here, I'm splitting that up. It's got adding in the power, and so you can split it up. So there's a 2 and a 2. So there are now 2 separate things. It's an e to the that multiplied by e squared. What's the rule for that? Let's just recall. You know, if you have something like e to the 6 times e to the 3, that's e to the 9, right? Camera issues. Come on, my lads, stay strong for me. What have you got? What have you got to offer? Okay, mild technical difficulties. Everyone pause for some hold music. Come on, I know you can do this. I know you've got what it takes. Gives you a chance, gives you guys a chance to see what you can do. Okay, give me 2 minutes, I'm going to try and fix it, alright? Maybe you guys see if you can do the next steps while I'm trying to pull off some sort of magic fix for it, alright? Sorry about this, I do apologise. New webcam is ordered, I can confirm that. But for now, we're going to have to persist with some dodgy difficulties. Let's see what's going to happen. Is there any way to resolve this? Let's try that, okay? I think that's doing it fun. It might be a bit slower or delayed, I don't know. Because it's going through Wi-Fi now. You don't care about the technical details. There's a bit of sun shining on me now as well. That's all right. It's on my good side. So, let's check how we're getting on. Okay, I'm continuing. That was a little pause for you, okay? You should be saying thank you. You should be saying, dear goodness, thank you for that pause. So there's the exponential rule. E to the 6 times e to the 3 equals e to the 9. You add the powers. Same here. You can go backwards. If I multiplied these two, it would be like getting that e to the this plus the 2. So I'm just kind of undoing it, if you like. Anyway, I can re-explain that if I need to later. Let's keep going. Now I'm going to expand out the brackets here. And you'll get e to the 2 x minus 2 squared times e squared plus e to the 2 x minus 2 squared. And on the right hand side, still haven't changed this guy. It's just laughing at the left hand side. Do you see what I've done there? All I've done is, this is one expression. I know it's horrible, I know it's like a big one, but it is just one expression multiplied. So you can just expand it out and do that times all of this, and 1 times all of this. Well, 1 times all of that, it's just the same thing. E to the minus 2 times all of this is, well, look, the e to the minus 2's will cancel out. Now, you need to convince yourself of that. I'll maybe just recap that in the turbo recap, but you got three things multiplied, e to the minus 2, and then you got that e to the minus 2. They'll cancel each other out. So you're just left with the thing in the middle. So that's what happens there. Okay, and now what am I going to do? I'm going to just take one big step now and kind of suggestively, well, let's do it in 2 steps, all right? 2 big steps and suggestively rewrite this thing. And maybe once you kind of know the answer of where we're going for, it might help see why on earth we did all this horrific stuff. So what was it? E minus e2 x minus 2 squared times e squared minus e to the 2 x minus 2 squared plus e squared. I think I got all the terms there. I just moved these 2 things over to the right hand side and made it 0 equals. One more, e to the 4 x minus 2. Now, minus, what have we got here? 1 plus, well actually it's going to be, that first one's e squared plus 1 brackets. So I'm kind of refactorizing it, so maybe I shouldn't have expanded it out there, but... And don't worry, stay with me guys, I know this is a monster, but you're going to get the rewards if you do persevere, because look, actually here's the first moment where you might have found some joy through the woods. You've already, I mean, look at what you've had to go through, but this is a moment where you've got this kind of setup, a quadratic-esque setup. So maybe just an absolute side project. Let's keep the side projects going. You might have seen this. You might have seen sine squared theta plus 2 sine theta plus 1 equals 0. Oh, that's maybe a bit too small writing it there. But, yeah. Or you might have seen something like cos squared theta minus 6 cos theta minus 2 equals 0. So things like this, if you do a substitution, cos theta equals x, you can rewrite it as x squared minus 6x minus 2 equals 0 and solve it like it's a quadratic. So that's the vibe of what we're going to do here. What's the clever substitution we're going to do? I can tell you, how much space have I got here? Slightly butchering this side of it. Right, okay, I'm just going to go. The substitution we're going to say is, let's call it y, right? Y equals e to the 2 x minus 2 squared. So that would mean that y squared equals e to the 2x minus 2 squared, which equals e to the 4 x minus 2 squared. Subbing that in, you'll get 0 equals, looks like y squared minus e squared plus 1 times y plus e squared. Just say that one more time. This is going to be some recap at the end, I can tell you. Oh, I'm liking it. Liking this question. We'll actually just do a mild recap already, and then we can do a fuller recap after. Started with something. Completed the square on that power. Simplified the completing the square. Multiplied this power and that power together using this rule. X to the a to the power b. You can multiply the powers. Gives you that now. Didn't touch any of the other stuff yet. Still only on that expression. Split it up into 2 using this rule, the rule of powers. So there you go. Next, multiplied out through that fraction thing. Not the fraction, sorry, the brackets. So you've got 2 expressions. Brought everything over to the right-hand side. Looks like that now. Suggestively wrote it like this, because it looks like it's in a form where we can make substitutions. Y equals actually just this thing. You notice if you do that and you square it, you end up with this thing. Therefore, that's a quadratic. A equals 1, B equals minus e squared plus 1, and c equals e squared. Now, I'm not, this is probably harder than, I'll admit, this is probably something that's harder than the new edXL spec, right? This is one of the very hard papers from Maths, but this is the kind of thing you need to practice. You need to be practicing this kind of thing if you want to get a chance to get a high mark in a new specification. That's exactly why I'm doing it. Continuing then, so there you go. You got your quadratic. That's a is 1, b is minus that whole thing, and c is e squared. E squared is just a number, right? You could put it in your calculator. It's not a variable. Y is a variable, e is not. So I'm continuing. I think I'll just use the quadratic formula now. You can maybe try and factorize that. If you're the, queen of factorizing 2019 national and continental level, you've got half a chance of that. If not, you're going to be saying, and I'll call it, we'll usually say x equals plus or minus. X equals negative b plus or minus square root of b squared minus 4ac. This could be a calculator job as well, to be honest. At this stage, you do have a calculator option. You could sit back and relax because you've been to hell and back with the algebra. You've got a quadratic formula. They're all just numbers. E squared plus 1 is a number if you put it in your cal. But anyway, I'm just going to do it here. What happens? Negative b, so b is that, so it should actually be e squared plus 1 plus or minus square root of b squared. Well, that would be e squared plus 1 all squared. Is that right? Am I doing everything good, do we think? Probably. Let's keep going. And then minus 4ac. Minus 4 times 1 times e squared all over 2 equals e squared plus 1 plus or minus. Well, what we're going to have to do here is probably multiply that out and that out, so you'd get e to the 4 plus 2e squared plus 1 minus 4e squared all over 2 equals. This couldn't be better practice if you're going to go and do a maths degree. Couldn't be any better. Doing the actual algebra step by step and seeing what comes out. At uni, in a maths degree, you get a calculator. That's right, you don't get a calculator, okay? Go tell the press. I want this on the front page of the Times, Guardian, and the Sun. You do not get a calculator in uni maths degree. So you need to learn your trade at this kind of thing. That looks like e to the 4 minus 2e squared plus 1 over 2. E squared plus 1 plus or minus, and then you can refactorize that. That will be e squared minus 1 squared over 2. E squared plus 1 plus or minus e squared minus 1, because look, that square root undoes the square. Oh, sorry, I need to move this up now. Wouldn't it be negative e? Yeah, that's true, Rachel. It would be negative that, but you're right. I just was a bit sloppy because you're going to square the whole thing. So even you're right. If there was a negative in at the front there, it's the negative all squared. So it's going to become positive anyway. So yeah, it was a little bit sloppy. I didn't write it, but that's true. What else? So got that thing on the top. Yeah, so it's that divided by 2. So that means you've got e squared plus 1 plus e squared minus 1 over 2. Sorry if that was a bit loud. Or e squared plus 1 minus e squared plus 1 over 2. Just check I did that right if you want. It's just algebra. This one, I'm just going to do it quickly. 2e squared, the ones cancel, divided by 2, that's just e squared. This one, the e squareds cancel. 2 divided by 2 is 1. Oh! Satisfaction of doing something like that. Unparalleled. Okay, micro recap of that part. You can see why this is a 12 marker, right? So there's A, B, and C. It's all it is really. I mean, like I said, you can put it in your calculator for us. We're just A level, and we're not necessarily expected to do this, but if you do this, you gain a lot. Plug them all in. That e squared plus 1 thing complicates things a little bit. Square it out, bring the terms together, refactorize it, and you notice that it looks like that. Then you can take the square root, and there you go, plus or minus, 2 answers, algebra, that's the 2. We're not actually quite finished yet, because we go back to our substitution. Here we said y equals e to the 2 x minus 2 all squared. Let's write that out again. Y equals e to the 2 x minus 2 all squared. And now we've said that that's our 2 answers are e squared or 1. So y equals e squared or 1. So now we need to convert our 2 answers into x. So we're going to have e to the 2 x minus 2 squared equals e squared. And we're going to have another one down here, which would be e to the 2 x minus 2 squared equals 1. Try and solve this one. This is probably a good time to log both sides. All right, we didn't actually do... That's interesting, isn't it? We didn't actually do much logs or any logs until this point. It looked like you might want to log it, but in the end, it wasn't really necessary. I waited this long, and now I could take log of both sides, and you get 2x minus 2 squared equals 2. X minus 2 squared equals 1. Square root of both sides, x minus 2 equals, oh hello, 1 or minus 1. Wow. So that means that for here you've got 2 answers. So x equals 3, and if you go this way, what have you got? X equals 1. See what I'm saying? You've got those 2 that came from the square root of that. Add the 2 to the 1 or add the 2 to the minus 1. You pick up 2 answers from that. How about from this one? Log both sides. 2x minus 2 squared equals, well, ln 1, I guess, right? If you log both sides. Ln 1 is actually 0. So you're ending up basically with x minus 2 squared equals 0. So take the square root, blah, blah, blah. X has got to be 2 for that one. So your final answer is x equals 1, 2, or 3. Wow, that's lovely. That is lovely to be able to get 3 answers out of it. And yeah, man, you're right. This is, yeah, if you go back and look at my other live math, this is probably the hardest question I've done, actually. If you check out the other videos, most of them will, from the first week and second week are EdXL questions, so they're not as difficult as this. Did some OCR and AQA as well, but now I just really want to push people, because people want the hard exam-style questions. People want to be challenged. The textbook's not enough for them, so we're doing the business here. We're doing the business here, and we're doing it together. Recap of that whole thing, and then I'm gone. I'm wishing you on your day, all right? There's a thing. All right, I don't know how else to describe it. It's just horrific. It's got e. Everything's e to the power of something, all right? They're just loving this idea of e to the power. So we take our algebra out of our holster, our leather personal engraved holster that we keep it in, and we start doing stuff. I'm thinking complete the square. Looks like that now, which is similar to the x minus 2 over there. Multiply or use the power rule, blah, blah, blah. What else did we do? Multiply out the brackets. You get 4 terms. Group them together suggestively. Make the substitution. There you go. When you get the substitution, it looks nicer. It's quite a difficult substitution to spot. Remember I mentioned these ones. These ones are a bit easier. If you got cos squared minus 6 cos theta minus 2 equals 0, usually you can sort of tell it's just x equals cos theta. Solve it like that and then plug it back in. Sorry if you've not seen something like that, but you can find that stuff pretty regularly in A-level literature. This stuff's a little bit, this substitution is harder. But when you do it, it looks like that. A is 1, B is that thing, C is that thing. Could use your calculator now, and you you'd find you'd get the answers, which ended up to be e squared or 1. If you did quadratic formula with that, no problem. You could definitely do that. Or you could take this extra page of algebra. Depends how good you want to be at maths. If you're just trying to get through this and get on with your life, then don't bother with this page. If you want to start practicing stuff and getting ready for uni and sharpening up your skills of not making sign errors, because you're going to do that, aren't you? Some of you, I mean, it's all right. It's okay. It's okay. I'm here for you. I'm here for you. And there are other public bodies who you can call to discuss your issues with, putting a negative sign when you should have positive. For example, here in that 4AC bit. Anyway, if you do it all through properly, factorising the bit under the square root, refactorising it like that, blah, 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 you'll get your answers. You do need to finish it off though because you had your y equals substitution. So you need to sub that back in and solve for x. With that first answer, which one was that? With the e squared one, that actually gives you two answers, 1 and 3. And with the one answer you got for y, that gives you x equals 2. 1, 2, and 3 final answers. Okay, thanks very much, guys. Like that one? Liked that one. Okay, only doing one more live maths for now. It's tomorrow. Big one, big one. Going out. Let's go out with a bang. So if anyone's got any other questions, thoughts, anything, I could do a bit of audience requests for tomorrow. I am taking requests. So if you want to send anything in, I'll try and look at it tomorrow. Otherwise, I'll see if we can find something exciting to go out with. Have a lovely day. Thanks for joining me. Give it a like if you haven't already. And yeah, next stream tomorrow, 10 a.m. 10 a.m. again on my YouTube. 1AS level question, 1A level question. Have a nice day. Bye, people. Bye-bye.